All right, let's go ahead and get started with our discussion on Orca today. My name's Heath Bartow. I'm a sales engineer here at Max Stadium. All right. So today we'll be talking about a few different things. The first is we'll be going over what Orca is, discussing what an Orca cluster is composed of, going through the basics of Orca, discussing a few advanced features within Orca, and then covering some Orca CI/CD plugins and a way that we can manage Orca through CI/CD. So Orca stands for Orchestration with Kubernetes on Apple. It's a piece of software we developed to connect into the Apple hypervisor framework, allowing us to create VMs that can be controlled as pods within Kubernetes, giving us fine control over the life cycle of that VM. It also allows us to very quickly and easily spin those VMs up and down, and also allows us to plug into different tooling in order to automate control of those VMs. An Orca cluster typically consists of a control plane, bare metal compute, which will be the macOS nodes within the environment, and then an image registry. We've got a couple different options for image registries. We can provide some storage within Max Stadium, or we can also plug into a customer registry as well, something like GitHub Actions or GitHub Artifactory or AWS. Basically, any registry that can support an OCI compatible image can store Orca images. The other features that can come with an Orca environment, there will be a firewall in front of the Orca environment, so we can set up site-to-site tunnels or other connectivity between the Max Stadium environment and a customer environment, or to the cloud, wherever your CI/CD tooling might live. We can also connect into your identity provider to allow you to use single sign-on to get into your Orca cluster. And we can also provide a virtual private cloud option to allow you to stand up Linux and Windows compute alongside your Orca cluster. The big benefit there is that it simplifies the network portion of the equation and allows direct access into that Orca cluster without needing to set up site-to-site tunnels, VPNs, or anything like that. So we'll go ahead and go into the demo. So the first thing for our demo is that we have a couple different ways we can access Orca. We can access it through an API, a CLI, or a web GUI. Those are how we directly access it if we need to make any kind of changes to the environment, if we need to do any kind of administration work. But most of our customers aren't going to directly interact with Orca. They're going to be using our CI/CD plugins in order to run their builds directly within Orca without any kind of interaction on their side with Orca. A lot of our customers tell us that their end users end up forgetting that it's backed by Orca because it's just so simple and easy to get set up. The different methods I have here, we'll take a look at CLI and web GUI during this demo. I've got a terminal here for the CLI, and then over here is our web GUI as well. I'll be hopping back and forth between these two to illustrate things or show things off. So let's take a look at what a node is, or what a cluster consists of. The cluster will run Orca 3 node list. A cluster consists of a number of nodes, each of these nodes being an underlying Mac Mini that's sitting within our data center, or with Orca Anywhere being released, can sit in your data center as well. We're flexible on your data center, ours, or in the cloud. You'll see that we have a number of different types of Macs in this environment. This top one labeled ARM Mini 001 is an M1 device. I've got a couple M2 Minis, an M2 Studio, and then recently I just got some M4 devices within my environment. So all of these are available for me to deploy VMs on, and all of them have a similar restriction in that I can only deploy a maximum of 2 VMs per underlying node. Orca is very flexible in terms of form factor. As I had mentioned, we have both the minis and the studio sitting alongside each other within the environment. We're also flexible in terms of architecture. We can have the ARM architecture sitting right alongside the Intel if for whatever reason you do have a need for Intel nodes within the environment. In order to run VMs on these nodes, we need to have images. So I'm going to run Orka 3 image list. This is going to show me the images that are currently existing within my Orka environment. And we have quite a few in this environment. You can see I've got an Azure DevOps image, a benchmarking image to check the performance of those VMs versus bare metal, a couple GitLab runners, TeamCity, Jenkins, so on and so forth. You'll notice a lot of them say that they are saved from VM, a VM name, and then a namespace. Mac Stadium typically provides 3 images, or the latest 3 operating systems in terms of support. So you'll see I have the Sonoma 90 gig Orca 3 ARM. Those are going to be the default images that you would use to build your images from. We also have Ventura and we also have Sequoia within this environment. So Mac Stadium will provide several images just to kind of get you a quick start on getting up and running so you don't have to build those from scratch. These images that I have listed here exist within my cluster. They're sitting in a terabyte of SAN storage that sits right alongside the cluster for quick deployment. But they don't have to live there. They can live within a remote repository if you want to store them there as backup or to deploy the VMs directly from there. And they can also live in several other places. The images are OCI compatible, so as long as your registry is OCI compatible, we can store them there. And they're also sparsely populated. So if I run Orca 3 image list and I run output wide, we're going to see a couple different things here. And I'm going to scroll up a little bit. So what we'll see is that these images on paper are 90 gig, but they only take up 17 or 18 gigabytes within our storage. We'll go ahead and clear that out. Again, Mac Stadium will typically provide base images for the latest 3 operating systems. So right now our support is Ventura, Sonoma, and Sequoia. We can provide older images if need be without any issue. Our M1s can go all the way back to, I believe, Monterey. So we should be able to provide that far back. And if you need even further back, the Intel devices can support just a little bit further back. In addition to the base images we also have what we call our quick start images. Those are going to be images with common tooling already installed, latest version of Xcode, Fastlanes, CocoaPods, things that you may need to get off the ground and building quickly, so you don't have to install those from scratch. It'll also have things like Homebrew so that you can quickly and easily install other tooling that you need. When it comes to the base images, Mac Stadium does make a few changes to those images. We install our VM tools so we can do things like resize the VM on the fly. We also do a few other things. We enable sharing settings for screen share and for SSH so that you can get into those machines. VNC is also enabled, but that is controlled at the node level. So even if you turn it off within the VM, you'll still have access into that VM through the node itself. And then I'd already mentioned the supported versions being the 3 most recent versions. So let's go ahead and take a look at what it'll take to spin up a VM. We had our node list, Orca 3 node list, and then we also had our image list. And if we take a look at our nodes, we can see we have quite a bit of available resources on several of these nodes. Nothing at all on the M2 Studios, nothing on the M4s. And there are a few VMs running on the ARM, on the M1s and the M2s. We can take a quick look at those and see which ones are running and get the connectivity information in, including the IP address, and then custom ports for SSH, VNC, and screen share. So we'll go ahead and deploy I'll run Orka 3 VM deploy. I'll specify an image. In this case, I know my benchmarking image is cached across my entire fleet. So I'll run that, and we should see within about 6 seconds that VM is up, its networking is ready, and we can connect in. The default username and password on the Mac Stadium images are admin and admin. We do need to specify that custom port of 8825 if we're connecting in through SSH. And we're within the underlying OS. Let me go ahead and exit out of that. As I said, we can connect in several different ways. The SSH is one way, but we can also get in through screen share if need be. Again, specifying that custom screen share port of 5904 and the username and password of admin and admin. And then we're into the underlying OS. From here, we can make any kind of changes we need to this VM. There we are. We can make any kind of changes we need to this VM. We can add any kind of software we need to on this VM. And once we're done with that, we can close it out and run an Orka 3 VM save or VM commit. If we run VM save, it'll do a kind of a save as function. We'll define the VM name and a new image name. That'll leave my current image, my benchmarking image, untouched so that when I spin down this VM, any future VMs that are deployed with that benchmarking image start from a golden state instead of starting from wherever I left it off. If I do want to overwrite that benchmarking, I can use Orka 3 VM commit. And again, the name of that VM. And that's going to overwrite my benchmarking image, and any changes I made will then be present on the next deployment of that VM by any of my nodes. From there, after we've committed this or saved it, if a node calls for that image and it sees that it's different from the image that exists in the registry or exists within the SAN storage, it'll pull that image down and then add that to the node. It'll take about a minute to 2 minutes, depending on the size of the VM. But after that, every future deployment will be about 6 seconds. The other option we have is Orka 3 VM push, and we can define again that VM name. And then we define where we want to push that. Running this will then push this to the remote repository. I have the repository credentials saved within Orka so that it can access that repository, but it'll save it there. And then again, any future VMs that rely on that will pull down the new image. One thing I will mention is that we do have several different ways to create images if you don't want to use the Mac Stadium images. The primary way I recommend is by using our free tool, Orka Desktop, to create those images. We can create a new VM, selecting either the latest IPSW file or any other one that you can source. Or we can pull from an OCI registry if we have images within the Orka cluster that we'd like to pull down and do some work on. After that, it'll either pull the image or the IPSW file. You can make your changes on your local device and then push it back to the cluster. And you'll see a push to OCI registry here. Once it's pushed back to the cluster, you can pull it back down or share it among anyone else who needs access to that image to make changes or to test with. Once we are done with that VM, we can run Orka 3 VM delete, specifying that name. And that'll clear up the resources for future deployments. And we'll see that had deployed on the .37 node, which would have been this very bottom M4 Mini 007 here. And we'll see its resources are back to available, ready to be deployed again. As far as the basics of Orca go, that's about all you need to know to get up and running to create the VMs, to modify them, and then to save them and delete them. There are a few other features that many of our customers take advantage of. As I mentioned, we have OCI compatible images that can be uploaded to registries. We also have the concept of namespaces since we're built on Kubernetes. So we can take any of these Mac minis and move them to a different namespace and put some users within that namespace, and then they'll have dedicated resources to their builds. So if you have multiple projects or multiple teams and you want to make sure they have a dedicated pool of resources available to them, you can spin them off their own namespace and then move some of their resources into that namespace. And from then on, they will have their own dedicated resources. If you don't need to go that far, but you want to make sure, say, one of your important builds builds on this M2 Studio with 24 CPUs and 128 gig of RAM, we can also tag those nodes in order to make sure that we deploy on that first or only onto that node. We can do that. If we look up here, you will see that we have this M1 right here is currently tagged as test. So if I deploy a VM and I tell it needs to look for a certain tag called test, and I tell it tag required, then this will only deploy on that M1 mini provided there is space. If I tell it tag, but I don't specify tag required, it will try to deploy on that M1 mini first. And if there's no room, it'll pick any of the other nodes within the environment and deploy on that instead. For some of the other things that are available within Orca, there is an image caching feature that has come out recently. This will allow us to take images that are within our environment or within a repository, and it'll allow us to add those images into the nodes ahead of time so that if we need to have that 6-second spin up time, those images are always ready to go. I'll show you how I use this with some of my CI/CD tooling here in just a moment. And we'll actually move over to the CI/CD portion of things. Again, this is my Orca cluster. It's got many of the same features within the GUI as the CLI. The only thing missing are a few of the Kubernetes specific features like namespaces. I can't create namespaces or move things within namespaces, but most of the other features are still there. So let's move over to CI/CD. For mine, I'll use GitHub Actions. I have several workflows within GitHub Actions to be able to control my environment. So let me just go to this one that's add or update repository. I'll run it first, just so we can see how it interacts with the Orca cluster. And we should see that pop up in just a moment. And while it's popping up, I'll go ahead and run Orca 3 VM list. And you'll see we now have a GitHub Actions runner popping up within my cluster. That's what's going to do the build. So let me go ahead and connect in. We'll take a look at the build. And basically what this build is going to do is, without me running it manually, it'll run every weekday at 2 a.m. It's going to grab my image that my users use to run their builds on. It's going to take the latest version of my code, cache it to that image. And then since Orca is accessible, the Orca controller is accessible to all of the nodes and to all of the VMs, I've installed the Orca 3 CLI within my VM. I then hit an internal API endpoint in order to pull the name of my VM. I then run a VM commit so that I can overwrite my VM and then run a VM cache. So when my users get in and start their day in the morning, they've got the latest version of my code on their machine. and they're ready to start building. And anytime there's any changes during the day, it's just going to pull the differential instead of pulling the entire code base across the network, which will make it a very quick build process for my users. And again, that'll run each weekday about 2 a.m. Without any kind of interaction on my part. Some of the other things I have in here as well that I use to manage my own environment. And let me hop back over here as well and run Orka 3 VM list. We'll see that GitHub Actions runner VM was also torn down automatically. So every single build will be an ephemeral build. We'll spin up the VM on demand and then spin it down as soon as our build is done, or when our job has defined that it no longer needs that VM. Some of the other things I have within here is I have a weekly build, and this weekly build will run every week. It will go in, it will update my homebrew, it'll update homebrew packages, so on and so forth, anything I need it to update within my image. And again, it'll run the same kind of process. It's going to set an Orca token. I generate a service account token. Those are long-lived tokens with a default lifespan of a year, but can be customized to whatever you need that token timeout to be. We'll commit the image. We'll wait for the image to be ready. And once it's ready, we'll go ahead and cache that image across the entire fleet. Again, that way when my users come in and they're ready to start building, they've got the latest tool set ready for them and the latest code. Some of these other ones are just little test builds here and there, so they're not incredibly important. But that's typically how I will manage my Orca cluster using just my CI/CD tooling. We have other plugins for Jenkins, GitLab, TeamCity, so on and so forth. Most of the major players out there we have plugins for. And when it comes to building images, we also have plugins for Packer to make it a quick automated way to build those images. And then we have a handful of other plugins you can find on our Orca Docs page as well. So any questions?
Keith, we had one question about if this would be available via recording, and it will. I answered that directly in the chat, but just for everyone else to know, yes, we can make it available to you in a recording if you'd like a permanent version of this, but nothing else in the chat at the moment.
Okay. Yeah, I'll go ahead and stop my share there. Give a few minutes, see if we have any other questions. And if not, as I'm waiting to see if any more questions come in, I'll take a moment to thank everyone for coming out and viewing this Orca webinar and getting some information on what Orca is, how it works, and how you can use CI/CD tooling to manage your Orca cluster automatically. All right, yeah, I'm not seeing any other questions. So if there are no other questions, then I thank everyone for coming out and hope you have a good rest of your day. If you do have any questions, feel free to email those in or to get those over to us, and we'll answer those and get you the info you need.